In this video, I'm going to go through how we can convert recurring decimals to fractions. Remember that we aimed to do this just to show that recurring decimals are rational numbers. Just a quick recap, rational numbers are numbers that can be written as fractions. And you get the integers, which automatically include the natural numbers, you get any fraction, and then you get the decimals. But there are only two types of decimals that can be written as fractions. They are terminating decimals, or finite, so the opposite of infinite, or recurring decimals, so those that repeat. And it might not seem too clear why recurring decimals can be written as fraction, or how they can be written as fractions, which is what we're going to do today. In class, if we covered this topic, then we probably only went through one recurring decimal, so 0.3 recurring, for example. In this video, I'm going to deal with more than one decimal place. So first, we're going to do 0.18 recurring. The aim is to get the number into a whole number form, and then we want to cancel things out. And we're going to do it using algebra. So I'm going to represent this number, this recurring number, by an algebraic letter. So I'm going to write, you can pick any letter, I'm going to pick X, and this is 0.18 recurring. Now, I've noticed some students writing this in class, which is wrong because you've terminated the decimal already. Either you continue with dots or you write your recurring symbol at the top, just to show that it repeats. Now, what we want to do right now is multiply this number by a multiple of 10, such that these numbers will end up at the front. So because I have two recurring values, I'm going to multiply my x by 100. And because I'm multiplying by a multiple of 10, I'm multiplying by 100, so I have two zeros, I will make this number bigger, and this decimal point will move two spaces. So I'll end up with 18.1818 recurring. So this is what you want to do. You want to get your repeated numbers to the front. So you have two repeated numbers, then you want to get two repeated numbers exactly to the front. And so you need to decide how many multiples of 10 you need to multiply by. So the next step, which is the quick step, is to subtract the two numbers from each other. So we have 100x minus x, and you can write it out if you want to, 0.1818 recurring, and subtract 0.1818 recurring. Now, if you notice that if I subtract these two numbers, the decimal places will cancel out. Notice that the first decimal place has 1, second decimal place has 8, third decimal place has 1, and so on. So this is what you want to do. You want to make sure that they match such that when you minus them, they cancel out. And therefore, you only end up with, on the right-hand side, you only end up with 18, which is this part, because it's minus 0. And on the left-hand side, you have 100x minus x, which is 99x. And so now you solve for x, and so x is equal to 18 over 99, and this simplifies to 2 over 11. So always simplify your fractions, and notice that we wrote x as being equal to this recurring decimal. So this whole recurring decimal, which goes on forever, can be represented by x, but we also found another representation for it, which is 18 over 99, which is equal to 2 over 11. So this recurring decimal can be written as a fraction. And this method can be used for any recurring decimal. So this is a quick proof that you can write recurring decimals as fractions, and therefore they are rational numbers. Now, if you understood up to now, you can stop this video and you can attempt some of the questions I'm going to do. If you're still struggling with the questions, please continue watching. So I'm going to continue with 3 decimal places. So I have 0.123. Again, this time I'm going to go slightly quicker because I explained all the details on the previous question. So x will be equal to 0.123 recurring. Because I have 3 decimal places now, I need to shift this decimal place 3 times. So I need to multiply by 1,000. So I will get 123.123.123 recurring. So again, make sure you're multiplying by the correct multiple of 10. If you only have one recurring decimal, so 0.333 recurring, so you only multiply by 10, which is probably what we did in class. Then you subtract these two numbers, so you have 1000x minus x, which is 123.123.123 recurring, minus 0.123.123 recurring. Again, notice that your decimal values match and they will cancel out. And so on the right-hand side, you'll end up with 123, and on the left-hand side, you'll end up with 999x. And so we solve for x, divide by 999 on both sides, and end up with 123 over 999, which simplifies to 41 over 333. So if you write this in a calculator, or 123 over 999 over a calculator, you'll end up with the recurring decimal. So this is the fractional representation. The last question, which I'm not going to go through, is this recurring decimal. It's good for you to have a practice for it. So 0.8765 recurring. And remember, you want to multiply by a multiple of 10 such that you get 8,765.8765 recurring, and so you want these numbers to cancel out. So you should get 800, your final answer. If you pause this video, you can attempt the question and then start it again to get the answer, which will be 8,765 over 9,999.